Welcome back for part 2 of 1.3. We're still talking about writing equations of lines. So the cash flow per share for Yahoo Inc. was 3 cents in 1997 and 30 cents in 1998. We're going to use this information to write an equation that gives us the cash flow per share in terms of the year and then predict the cash flow in 1999. Now, the important thing I want you to get out of this problem is thinking about how to write information in a more familiar way. Let's say that X equals the cost per share, or the number of years, excuse me, after 1997, and Y is the cash flow per share. Just the cash flow for short. So now, the year, if we're starting in 1997, that can be year number 0. And our share price was 3 cents, so 0.03. In 1998, that's year number 1. And our share price was 0.3 cents. Now, this is a more familiar form. We're used to working with these ordered pairs. So what we can do is we can find the slope, y sub 2 minus y sub 1 over x2 minus x1. So it's going to be 0.3 minus 0.03 divided by 1 minus 0. So what we're going to get is 0.27 divided by 1. So that's going to tell us that our share price, our slope, is 27 cents. Now, normally we'd have to find the y-intercept, but for this one, we don't. We know the y-intercept is when x is 0. That's already there. So our equation, y equals 0.027x plus 0.03. There's the equation that we can use to predict the cash flow for any year after 1997. So 1999, what we can do is we can take 1999 and subtract 1997, our starting year, and we get 2. So that tells us that's year number 2. So x equals 2. So y equals that's actually 0.27. Ignore that extra 0 there by accident. 0.27 x plus 0.03. So y equals 0.27 times 2 plus 0.03. So y equals 57.57. So the cash flow is 57 cents, $0.57 in 1999. Like I said, the important thing from that problem is knowing how to write information as an ordered pair in a more familiar form. Going to the next page. Once again, 1980, average price was 100,000. 1985, the average price was 120,000. Write the linear model for the price P in terms of the year T. And they're telling us right here that T equals 0 is year number, or 1980. So 1980 is year 0. So we can write an ordered pair, 0, 100,000. Our variables are already defined, so that's why we don't have to do it. 1985 would be year 5, and that's 120,000. There's our 2 points. Let's find our slope. y2 minus y1, x2 minus x1. So we have 120,000 minus 100,000 divided by 5 minus 0. So we're going to get 20,000 divided by 5. So the slope is $4,000. So the change was $4,000 per year. That's how much the house values were increasing. So now, once again, we don't have to find the y-intercept because it's already given to us. Year 0, 100,000. That's our y-intercept. So now the price, P, equals 4,000 T for the number of years plus 100 There's our model for the home prices in that county. Number 7. A sub shop purchased a pizza oven, used one, for $875. After 5 years, the oven will have to be replaced. So if it has to be replaced, it's really worth no value. So now let's think about X equaling the number of years and Y equaling the value of the oven. So we can write as ordered pairs. In year 0, that oven is what we paid for it, $875. In year 5, that oven has to be replaced. It's not worth anything to us. So it's worth 0. So there's our ordered pairs. So the slope, once again, y2 minus y1, x2 minus x1. So it's going to be 0 minus 875 over 5 minus 0. So it's going to be negative 875 divided by 5. So it's going to be negative $175, which makes sense because it's losing value each time. So it's getting less and less valuable. So our equation, y equals negative 175x plus 875. That slope is negative because it's decreasing in value each year. Once again, you want to think about writing as ordered pairs and picking out a good year 0 so you get that y-intercept for free, basically. Number 8. This is a 2-part question. We're looking for an equation in slope-intercept form that passes through 2, negative 1. It's parallel to 2x minus 3y equals 5 and perpendicular to 2x. So it's parallel to the same line as it is perpendicular to. Now, parallel lines have the same slope. Perpendicular lines, their slopes are opposite reciprocals. So what we need to do is we need to find the slope of the original line, which we don't know by looking at it. It's in standard form. We want it in slope-intercept form. So to get y by itself, subtract 2x from both sides. Negative 3y equals negative 2x plus 5. Divide everything by negative 3. Y equals 2/3 x minus 5/3. All I cared about was that the slope was 2/3. I can throw the rest of the line away. I don't need it anymore. Just wanted the slope. So for part A, parallel. So that means our slope of the new line is 2/3. I'm going to use my point slope form. Y minus y1 equals m, x minus x1. So my point is 2, negative 1. There's my x and my y. Y minus negative 1. Sorry about that. Y minus negative 1 equals 2/3 x minus 2. So you get y plus 1 equals, and distribute, you get 2/3 x minus 4/3. Subtract 1 from both sides. Y equals 2/3 x. And now we have to get a common denominator for the last 2 fractions of 3. Negative 4/3 minus 1, which is 3/3. So y equals 2/3 x minus 7/3. And there's the equation of this line in slope-intercept form. That's for the parallel. Perpendicular, the slopes are opposite reciprocals. So the opposite reciprocal of 2/3 is negative 3/2. Same thing again, y minus y1 equals m, x minus x1. Y minus negative 1 equals negative 3/2 x minus 2. Y plus 1 equals negative 3/2 x plus negative 3/2 times negative 2 is a positive 3. Subtract 1 from both sides. y equals negative 3 halves x plus 2. And there's the equation of our line in slope-intercept form. Now to finish up, problem number 9, we have the lines through these 2 points and through these 2 points. Are they parallel, perpendicular, or neither? To determine that, we want to look at their slopes. M equals y2 minus y1, x2 minus x1, 4 minus 2, negative 1 minus negative 8. So you get 2 over over 7. So our slope is 2/7. For the second line, we'll call that m sub 1 and m sub 2, y2 minus y1 over x2 minus x1, 7 minus 0 over negative 7 minus negative 5. So it gives us 7 over negative 7 plus 5 is negative 2. Now, we don't want to leave it like that. We would commonly see that written as moving the negative up front or up top, negative 7 halves. And if you look, 2/7 and negative 7 halves, they're opposite reciprocals, so the lines are perpendicular. They're opposite reciprocals. The important thing to think from today's lesson, parallel lines, same slope. Perpendicular lines, the slopes are opposite reciprocals. Labeling your variables, defining your variables, and also making sure to set up in an easy way so that you have your ordered pairs from the given information. Thank you.